Can everybody, is everybody okay if I don't use this? Okay. Because I know Sarah's doing a test and I just want to make sure that. So lesson number 1, characteristics of quadrilaterals. Okay, so let's unpack this thing and see what this is about. So if we kind of play with the words or chop up the words and see what it means, the word quad means 4. Quad means 4, right? Like when anything you hear the word quad, it's 4. And then the word lateral, it means pertaining to the side. Pertaining to the side. So when you put it together, quadrilateral, it means 4 sides. So anything that's 4-sided figure, we're gonna take a look at their characteristics. Now, each one of, yeah.
Can you say what it was for laterals again?
Oh, laterals means side. Means 4. So 4-sided. So 4-sided figure. Last unit we talked about triangles, right? Last unit we talked about the triangles and then we looked at the different characteristics of a triangle. One characteristic is that in a triangle there are 3 sides, 3 angles, and the sum of all the angles is 180. So those are the overall characteristics of all the triangles. Now, what are the characteristics of quadrilateral? So quadrilaterals are 4-sided figures. We know that. If 4 segments are used to construct a figure, there could be several types of quadrilateral that we can create. So each type of quadrilateral has different properties. So we can take a look at their side lengths. We can take a look at their parallel, perpendicular, and other sides. Okay, parallel sides, perpendicular sides, and whatever sides they have. We can also describe a quadrilateral based on their diagonals. And then the diagonal, what does it mean? So diagonal is a line that stretches from one corner to the other corner. We'll talk about that in a second. And we can also describe a quadrilateral using the angles formed at the intersection of diagonals. So intersection, what does it mean by intersection? Where they meet, right? Like where they meet, right? And the word bisection of diagonals, the word bi means 2, so 2 parts of a diagonal. So what does that look like? Does it bisect? Does it cut in 2 equal parts? We'll see that. The size of interior angles, and then the sum of all 4 interior angles is always 360. We will investigate why that is true. Okay, so the different types of quadrilaterals have been shown below. So this one is called a parallelogram. Parallelogram. What is a parallelogram? How would you describe a parallelogram? Okay, this is how I would describe a parallelogram. Imagine a rectangle. Okay. So let's use our imagination. Let's imagine a rectangle. And then with the rectangle, I have to draw it out. So we're going to imagine a rectangle first, because we all know what the rectangle looks like. And then let's say this is a very flimsy rectangle. You can turn things around here. So what I'm going to do, we're made out of sticks. So I'm going to push this corner here. Okay, let's imagine in our brain, I'm pushing this corner here. What's going to happen? It's going to slant. Yeah, yeah, our idea is that this is gonna slant, but because this is attached to this thing, then that means this is also gonna slant, right? And it's gonna slant in the same amount. So now, because I've pushed one corner here, and everything, this line will shift right here. So this is the original line or side, and it's gonna be pushed this way. This is the original side, now it's gonna be also pushed this way. So now, what does it look like? It looks like we started off with a rectangle, okay? We started off with a rectangle, and now it kind of looks like a slanted rectangle. That's what a parallelogram is. So that's how you would describe it. And these three examples are examples of parallelogram. So let's take a look at the characteristics. How do we know what are the characteristics of the parallelogram? Do you have your booklet? Do you have your booklet?
It's not in there now.
No? Oh, okay. Oh yeah, I have one over there. So let's take a look at the side lengths. Side lengths. Now, before we talk about side lengths, congruent. What does the word congruent mean? Congruent. Have you heard of the word congruent before? We don't use the word congruent a lot. This dictionary doesn't have the word congruent, so I'm gonna search a different dictionary. Identical? Yeah. Identical? Yes. I'm gonna check the big dictionary. That was pretty thin. That's a pretty thin dictionary, so I'm gonna take a look at the word congruent. So sometimes when I don't understand something, or there's some words that are brand new to me, I look at the dictionary, and dictionary congruent.
Identical in form, coinciding exactly with the
That's right. Identical in form. Did you guys Google that? That's so fast.
Yeah.
I'm doing the old-fashioned way. Congruent.
origin, Latin where
There's a Latin. Came from Latin.
congruent.
See?
Meeting together. Meeting together.
Mm-hmm. There, finally found congruent. Let's see that. See, Google is so helpful. It took you like 10 seconds to do that. It took me like 2 minutes. So it says here, in math, they even have a this is the word congruent used in math. Can you see that? It says here, coincidingly exactly superimposed. What does superimposed mean? When you put them on top of each other, they're exactly the same. Okay? So that's what congruent mean, exactly the same. Wow, that took us like 2 minutes to figure that out. Probably more. So side lengths are, any side lengths that are congruent?
Yes.
Which ones do you think are congruent? Hmm?
Diagonally? No.
I'm gonna, you have this one. Do you see anything? This one is congruent with on the other side, right? Yeah, other side. What about this one? The one above, right? On the other side. So how do we say that so that we can say, oh yeah, two sides are congruent, but it's not these two that are congruent, right? It's the one over there, not the one beside it. So we can say, how do we do that? How would you explain that?
Two sides, two lengths.
Say that again.
Two sides and two lengths.
Two sides. Okay, so these are two sides.
I'm guessing.
Okay, no, that's okay. We have to make sense of this, because if we could describe it, probably make it easy for us. So how can we say that these two and these two are congruent?
Diagonal lines. Can you say that?
Now the diagonals is now this one here and that one there.
Would be height and width.
Height and width. Oh, okay. Height is actually this height, not this one. So think of this as like, oh, this side and this sides are
Parallel.
opposites to each other, right? They're opposites of each other, and these two are opposite of each other. So we can say opposite sides are equal or congruent, right? They're opposite sides, opposite, right across from each other, right across from each other.
Opposite sides are congruent.
Yeah, opposite sides are congruent. Do you see any parallel lines?
That would be
So-
perpendicular to the side, right?
So let's take a look at parallel. What does the word parallel mean?
We run alongside each other but not touching.
Yeah, it could be. You know, like every time I ask, like, what does it mean by parallel? Like people start going like this, or like, like going like this with their hands. What's that? Like parallel parking? Yes, yeah, parallel parking, right? Yeah, so you can, if you're parked this way, you're parallel parked this way. Not like that, right? That's not parallel parking. Now we're getting into driving. So parallel side. Okay, describe which ones are parallel to each other in these.
Both the parallel lines are parallel. Both horizontal lines are parallel. And
The two slants are parallel.
Yeah.
Okay. So how can we say that? Okay, that's exactly what it is. So these two are parallel, these two are parallel. That means they're going in the same direction, right? So we can say also opposite sides
are
are
congruent.
congruent. So this one here is very interesting with parallelogram. Opposite sides are equal and opposite sides are parallel, right? So they're the same length and they're parallel. So these two lines. Oh, parallel, thank you. Jeez. Parallel. Thank you. Yeah, so opposite sides are congruent. Congruent, that means the same length. And they have this, they're going in the same direction. The next one here. Perpendicular. What does a perpendicular mean? Yeah, we all know what parallels are, right? Parallel going in the same direction. Perpendicular is when they create a 90-degree angle between the two sides. So the rotation from one to the next line, 90 degrees. Do you see any 90 degrees around here?
Yeah, I guess there would be. Well, never mind.
Yeah, but no.
Yes, but no, okay.
If you're to
Move it back into a rectangle?
like first parallel.
No, we're not putting it back in a rectangle.
So then no.
Your parallelogram.
Uh-huh.
If you're to connect.
Those two are smaller.
If you like meet right in the center.
The answer would be no.
Oh, you're talking about these ones. These
That
ones?
would be a 9-degree right there, wouldn't it?
I-
Yeah, so be 60 right around, but one pi would be 90.
Right now we're talking about the sides. Yeah, we'll talk about diagonals later. We'll just talk about the sides. Any sides perpendicular? Do they make 90-degree angles?
No.
No, right? So, perpendicular sides? No. No perpendicular sides. Well, I kind of heard somebody say bigger than 90 and smaller than 90. Which angles are bigger than 90?
Obtuse.
Obtuse? Yeah, these two are bigger than 90, right? You can see that if this is 90 degrees, the other one is slightly bigger. Yeah. And do you see anything that's less than 90 degrees?
Yes.
So these two are less than 90. So nothing. No perpendicular sides. Now let's move on to diagonals. Let's move on to diagonals. Are diagonals congruent? Means, do they have exactly the same length? Okay. Now these are the diagonals. Two. Okay. How can we show that they are congruent or not congruent? How can we show that this line and this line, are they congruent?
Yeah.
Okay. So congruent means they're exactly the same in shape and form and size, right? Exactly the same in. So should we measure it? Let's see if it's congruent. I happen to have a ruler. Somewhere. Any guesses? No? You're saying no? That's a guess, okay. Well, we can make a guess. We can make a guess. But why guess if I could measure it out, right? Okay, so I'm gonna measure this diagonal. Everybody could probably see that one. It looks like about
1.4.
yeah, about 2 to about 2.5, right? 2.5 centimeters or 25 millimeters, okay? What about this diagonal? Huh, it's 4 centimeters. Are the diagonals congruent?
No.
No. The diagonals are not congruent. Now, why is that? Let's just take a look at this thing again. Okay, this is my drawing. Remember I said we started off with a rectangle and I pushed one corner to the side and then kind of gives us a slanted rectangle, which is now a parallelogram. Does that look if you look at this one, because this is like pushed to the side, it kind of stretches this diagonal out more, right? So this is longer than this one. So yeah, the diagonals are congruent? Nope. Are diagonals perpendicular? Okay, here are the diagonals, right? There are 2 diagonals. Are they perpendicular? Meaning, do they make a 90-degree angle from one to the other?
Yeah.
Okay, well, how would you know? How would we know?
There's 4 equal pieces.
Okay, there's 4 equal pieces. Yes.
That by 360.
Yeah, 3. Okay. Let's see. Well, I have a protractor. Okay. Let's see this. I'm gonna do it sideways this way. So here's my protractor. It starts from this angle or from this line and then rotating to the next diagonal. Does that look like 90-degree angle to us? So this one, this is the diagonal. Did they make 90-degree angle? No. Okay, so no, doesn't make a 90-degree angle. Okay. So the answer is no. Okay, so, well, what's so special about these diagonals? They're not equal to each other, they're not congruent, and they're not creating a perpendicular angles. Let's see. Do diagonals bisect each other? Okay, now let's take a look again. What does bisect mean? Bisect means 2 parts or 2 sections. And it becomes 2 equal sections, 2 equal parts. So do the diagonals cut each other in equal parts? Now, let's look at this diagonal. Think of this as like a knife. Does that bisect this one? Yeah, it does. Okay, so this is equal and that's equal. So yes. Now what about this one? If this is my knife, cut it like that, it will cut this diagonal into 2 equal parts. 2 equal parts, yes. Diagonals bisect each other. That means they cut each other in 2 equal parts. And then last one, angle sizes. Are any angles equal size? Yeah, so which angles are equal? These two corners are equal to each other, and these two corners are equal to each other. So how can we describe that these two and these two are equal? Opposite, yeah, opposite. Opposite angles are equal to each other. So whatever. And if you look at this picture, that kind of gives everything away, right? Because this angle and then this angle, they have one tick mark. That means those two angles are equal to each other. These two angles, they have two tick marks, those tick lines. They're equal to each other. And then if you take a look at this one and this one, they have both two tick marks, like equal, equal. Do you know what this sign mean? Symbol? Going like that?
Forward.
Going forward, okay. They're both going in the same direction. If they're going on the same direction, we say they are parallel. Okay. So that means these two opposite sides are both equal, see, and they are both parallel. And then this one, these two sides are both equal. You got those marks there. And then you have one arrow going this way. That means they're going in the same direction. They're parallel to each other. Okay? So, interesting. It says here, the parallelogram has several shapes that are also considered special parallelograms. They're special, but they get their own names. A rhombus is a parallelogram, but we're going to talk about that in a second. A rectangle is also a parallelogram, but especially has a special characteristics. A square is a parallelogram, but it also has a special characteristics. Let's take a look at this now. These are the special parallelograms. Now, I think the next few ones would be a little bit faster. Okay. Side lengths are any congruent. We already know the symbols, right? So, any side lengths are congruent? Yeah. So, how many side lengths does it have? There's 1, 2, 3, 4. Okay. In this case, can you see there's all one tick mark on each? So what does that tell us? Yeah, all 4 of them. All sides are equal. Okay? So if this is 4, this side is 4, this side is 4, this side is 4. Any sides parallel? You see any sides that are parallel? So this side and this side are parallel. This side and this side are parallel. So how do we describe those? Opposite, so only these two are parallel and then only these are parallel. Yeah, we can say opposite sides are parallel. Any perpendiculars? Do you see anything that creates a 90-degree angle in terms of sides? No? Are diagonals congruent? Okay, let's measure it out. Remember it got pushed this way, so I'm gonna measure it out. Okay, I gotta prove to myself or show myself, are they equal, diagonal? So I'm gonna look at this diagonal and then this diagonal. So this one is 20 millimeters, 20 millimeters, or 2 centimeters. What about this one? This one is 3.5. So one diagonal is 2 centimeters, and then the other diagonal is 3.5 centimeters. So they're not the same. So are diagonals congruent? No. When you see something like that's getting tipped over a bit, it stretches the diagonal on one side. Are diagonals perpendicular? So if we measure this angle here, are they diagonal? Let's see. So one arm is right here, and then the other arm of the diagonal is right there. Makes it 90-degree angle. So that one makes it perpendicular. So the other one is yes. I'm gonna just draw this piece over here. Just one. Do you see a triangle? So if you just focus on this piece, it just actually shows you a triangle. And what does that little square, that right there mean?
Right triangle.
A right triangle. Yeah. So if you focus on that one tiny bit of a triangle right there, it creates a 90-degree angle there. That one. Okay. It creates a right scalene triangle. Right scalene triangle. So are the diagonals perpendicular? Yes, they are. Do diagonals bisect each other? So does this line cut this line in half? Yeah, it does. So yes. And any angle sizes that are equal. Opposite sides, or sorry, opposite angles are equal. Meaning, let's just draw it out again. A rhombus so these opposite angle are equal, and then this angle, opposite angles are also equal. Good. Can I tell you what a rhombus looks like? Oh yeah, it kind of looks like a diamond, yeah, when you kind of go like that. Or a kite. It actually looks like a square. And then again, pushing it to the side, one corner rather. If I push this, what happens is it starts to tip over. So a rhombus is really, when you think about it, You play with this in your mind. Play with this in your mind. You push this side, this whole line shifts that way, and then because they're interconnected, this also shifts down. Yeah. So it's like a rhombus. I think about rhombus as a square kind of tipped over a little bit. Now rectangle. Oh, everyone knows about rectangle. So let's take a look. This one's going to be a little bit faster too. What about side lengths? Any side lengths that are congruent? Yeah, opposite sides. Opposite sides are congruent. Any perpendicular sides?
Yeah.
Yes? Okay. Yeah. Now, can we say opposite sides are, oh, sorry, I jumped too far. Parallel sides, yes, opposite sides are parallel. Okay, so if you look at this side and the one opposite to it, they're parallel, they're going the same direction. What about perpendicular? Sides are perpendicular. Can we say opposite sides are perpendicular? Can we say opposite sides are perpendicular? No, we can't say opposite sides are perpendicular, but we can say this side and this side are perpendicular. Yeah, you can come in. So how can we say that, hey, this side...
Sorry, I have an emergency appointment. I want to leave.
Okay. We can't say opposite sides are perpendicular. We can say this and this are perpendicular, and this and this are perpendicular. How can we say that? Have you heard of this word before? Consecutive. Okay, now you can Google it if you want. It's probably faster if I check the dictionary here.
Consecutive.
Yeah,
one
what this?
side after one side after the other.
That's right. The word consecutive means one side after the other. Okay, that's what consecutive means. One and then the next. So if this is the side, then the next side is perpendicular. And then this side and then this next consecutive is perpendicular. And so on. Okay. Any diagonals congruent? Okay, so this is the diagonal and then this is the diagonal. Yeah, diagonals are hard to figure out at this time. Are they equal to each other? Are they congruent? I gotta measure it out, okay, because I'm not sure. So this one, I measure it as about 60. No, yeah, about 5.9 centimeters. And if I go this way, oh, also about 5.9 centimeters. So, are the diagonals congruent? Yes. Diagonals are congruent.
Right now the rectangle is what's that?
Yeah, in a parallelogram it's not, but in a rectangle it is. Yeah. What about diagonals? Are the diagonals perpendicular? Do they make 90-degree angles? Do you see a 90-degree angles around here? No, because it's, remember, 90-degree angle has to be like the L shape, right? Do diagonals bisect each other? You sure about? Yeah, you sure about that? Yeah. 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 They cut each other in half, and any size, angle sizes, any angles that are equal to each other. Can we say opposite angles are equal to each other? Opposites, but all of them are 90. So what can we say? All interior angles are equal to 90 degrees. Okay, I gotta stop right here. Okay, stop right there.
All
Uh,
interior angles are equal to
are-
90 degrees.
Right. So this is 90.
Oh,
This is 90. This is 90. Yes? Okay, so great. That's a good place to stop.